over dt equals 2/3 dx over dt. So, so I have to repeat a little bit here because I stopped the video and I forgot to start it again. So for those who are not here, allow me to repeat, and maybe that helps everyone also. So the small triangle is similar to the big triangle because they have equal or congruent angles. Common angle is the same, and this is the right angle, same. Therefore, these have to be the same. Because the small triangle is similar to the big triangle, I can write proportions with their sides. But this is not random. It's specific order. I start with the common angle. The opposite is 6. The opposite side. The opposite side in the big triangle is 15. The opposite, I'm back to the small triangle. The opposite of the 90-degree angle is A. The opposite of the 90-degree angle in the big one is B. But I cannot use this because I don't have any of those measurements. And then I move on to the last angle. The opposite of this is Y, and the opposite of this, they're equal, congruent, is X plus Y. That's why I have Y and X plus Y. These three sides come from the small triangle. These three sides come from the big triangle. Again, a proportion, you told me to cross multiply. I did. I moved 6y to the other side. I got this. And I know that these are both functions of time. So then I have dy over dt equals 2x dx over dt. So then dy, when I replace dx over dt by 5, I get that dy over dt equals 10 over 3. Of course, it has to be feet per second. But they're asking us to determine this rate of change of this. So then we have to add these two. So dx over dt plus dy over dt equals 5 plus 10 thirds. So 15, so it's 25 thirds feet per second. So that's the answer. And you can say, wait a minute, you're not using the 30 feet. I'm not, because there is no need for it. They're only telling us this, we're really asked to determine the rate of change of this. This is given to us, we found this, but now the rate of change of this is the sum of the two. So they're telling us, hey, we need the sum of these two rates of change. That's why they're giving us that 30. Any questions about this, Tom? Any step? Do I need to repeat or review any?
No, I think I'm good.
Okay, perfect. Other questions? Anyone would like or needs help with anything else? Anyone? Okay, so let's go back to the list. And please tell me what you would like to continue with. Derivatives are all different functions. Implicit differentiation, logarithmic differentiation, the particle with the velocity, the acceleration, etc., 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 etc. Approximations and linearization. Please pick a topic so we can continue. Anyone, please?
I'm looking up a problem. Just a moment.
Please do. I'm ready when you are. Any problem in WebAssign that you need help with? If you find something else before Evelyn, please let me know. Landon, Tom, other problems? that you would like us to discuss? If not, I will pick problems.
Professor, you can go ahead and choose problems. I'm still searching.
Oh, I can share. Are you looking at related rates or something else?
I'm looking at related rates, yes.
Okay, so I can share the screen. So we did number 4. Okay, till you find something, I will continue with the first topic of derivatives. So let's look at y equals tangent x over 1 plus cosine x. We want to find y prime. When you find it, Evelyn, please let me know. So can anyone tell us which rule applies here?
This will be the quotient rule.
Perfect. So for the quotient rule, remember, we have to have the denominator squared. When we differentiate tangent, what do I write? The derivative of tangent. Anyone, please? The derivative of tangent. Okay, so that's secant
squared x.
Okay, 1 plus cosine x, thank you very much, minus tangent x. Can anyone differentiate, because 1 prime is 0, can anyone differentiate cosine x for us?
Negative sine x.
Yes, awesome. So all I can do is now remove parentheses. So I have secant squared times 1 plus secant squared times cosine x plus tangent x times sine x over 1 plus cosine x squared. Even if I change this into 1 over cosine or secant, actually this is basically secant, I cannot further simplify, so this can stay. Okay. What about, for example, y equals the square root of t times natural log of t to the 4th. Okay. First, we're differentiating the outer function. When I differentiate the outer function, what do I get? What is the first step? Anyone, please? When we differentiate the square root, what do we get?
1 over 2 roots, whatever.
Yes. Good, but not sufficient. Times see, if this were x, I would have stopped here, but this is not x. So times what? What am I saying here? What do I have to write in here? Anyone? What am I expected to write in parentheses here? Don't give the results, just tell me what I need to do. So what am I?
The outer function.
But that's the outer. We already differentiated the outer. So every time after we differentiate the outer, we always say times what? Times the
In a function.
inner function prime. So let's differentiate the inner function. What do I write? Which rule applies here? In order to differentiate this, which rule applies? We have to identify the rule we apply. Otherwise, we can figure out what to write here. So which rule applies here? How is it called? Here we apply the quotient rule. What do we apply here?
Product rule.
Yes. This is the product. The first function prime is 1 times natural log t to the 4th plus t times, you can put 4 in front if that's what you want, times natural log t prime, which is 1 over t. It's the same thing. So we simplify. So we have the final answer. I will have natural log t to the 4th plus 4, everything over 2, the square of t times natural log t to the 4th power. Any questions on this function? Any questions on this function? Any questions?
Can you do another example like that one, please?
I don't know if I can find exactly like this one. I got it from the book. It's here on the review. It's problem 36 on page 270. So 36 on page 270. I don't know if I can find another, but for example, 17 may look similar. In 17, we have y equals the square root of arctangent x. So let's differentiate this one. Okay, so then y prime. Anyone would like to give it a shot?
Over 1 over 2 times the square root of arctan x. Times.
The inner function prime. Times the inner function prime. Anyone remembers arctangent prime? Anyone? Arctangent prime?
That we
Arctangent prime is 1 over 1 plus x squared.
plus x squared.
Yep, that's it. That's it. Okay. Let's see, anything else? What about let's say f of x equals log base 3 of 5x squared plus 3x. How do we differentiate this? So when it's natural log of 5x squared plus 3x prime, we have 1 over 5x squared plus 3x times the inner function prime, which is 10x plus 3. And we should, in the denominator, right, we should divide by natural log e, but we don't because it's 1. So this is the only difference here. It's the same thing, but we do have to have natural log of 3. So the formula is the same. It's still 10x plus 3. Same thing in the numerator. Same thing in the denominator. But we have to multiply by natural log 3, this one. When it's natural log, it's 1. That's why we don't need to write it. Okay. What about implicit differentiation, like cosine x squared y equals 2x to the third plus y to the fourth? Do you have any questions on the previous problem? Questions on the previous problem? You are going to have the tables of integrals, right, with you, with all the lists, so you don't miss any formula, right? Yes? Anyone, please?
Yeah.
Okay. Good. Can anyone start differentiating? Can anyone, would you, let me just say,